Hi, in this video we are going to discuss about the basics of linear algebra because the linear algebra very basic things that we have to know before learning about the machine learning topics. Okay, in this we are going to discuss about the what is the vector. Okay, what is the vectors and how can we represent those vectors, what are the difference between vectors and scalars. Then we are going to discuss how we can find the distance between the vectors and yeah, that is the thing. And then we are going to discuss about the how we can make addition and multiplication of two vectors or any number of vectors. We don't care about the thing. These are the things that we are going to see in this video. Okay, firstly we will talk about the vectors. Yeah, I think you are already know about the vectors, but I want to recap few things. uh, I think you already know the difference between the vectors and the scalars. Scalar is a vector and a vector is a sorry scalar is a value and the vector is a scalar representation with some direction. What is the actual meaning? Okay, for that let's consider an example. Okay, a bus is there and some person is given the location of the bus at time t. The location of bus means the latitude and longitudinal values like 32 degrees and 29 23 degrees. Okay, these are the scalar values. It was only represent the location of bus. If we represent this one with a vector, we also get the direction, the in which direction it was moving. It is moving in north, towards north or south or east or west. Those things we will get by representing these values in the vector. Okay, these are the benefits that we will get. These benefits we are going to use in the machine learning. Let's see how we are going to represent the vector in 2D and 3D spaces, because it is very easy to represent and visualize the things in 2D and 3D spaces. That's mostly we are going to use 2D and 3D space for anything. Then we are extend to the any n dimensional space, because it is very to extend from 2D to n. Okay, uh, this is the point in the 2D space. Let's consider point P. This is the point P, and it was represented with value a1, a2. Here the x1 is the this is the point with values a1 comma a2. Okay, this one is the x1 component. Okay, this one is the a2 is the x2 component value. Okay, but it is a point. To convert this point to the vector, it's need to be some direction. Okay, and to give the direction we will just represent like this. Okay, now it has a direction, that it's a vector. Similarly, in the 3D space, let's consider point P, a1 comma a2 comma a3, and this is also a point. Now to represent this point as a vector, we need to give direction. Now the point has a direction. Okay, that is the direction, and this is also now as a vector. And p equal to a1 comma a2 comma a3. Okay, uh, okay. a1 a2 a3, there's a x1 component, x2 and a x3 component. Similarly we can also extend to n dimensional a1 comma a2 comma an. Okay, but generally in the machine learning algorithms we are using the in vector represent vectors we will represent in the matrix formation. How we can represent a vector in matrix form? Just like p equal to a1 comma a2. It's like if you want to represent as a row vector, it's like a row, it is a row vector. If you want to represent as a column vector, we can represent, no problem, like p equal to a1 a2. Similarly, this one also, p equal to as a row vector a1 a2 a3. If you want to represent as a column vector a1 a2 a3. Okay. Similarly, for the n dimensional also, a1 a1 a2 an. For a row in a column vector a2 a3 an as a column vector. Okay, and now let us see, this is the representation of the whole vector in the 2D or any dimensional space. It was look like this only. And now let's see how to find the distance between two vectors, and that is the thing we are going to discuss now. For that, let us create once again 2D space. Now let us see how to find the distance from between two vectors. Before going to that, we are going to see the distance from origin to the point. Okay, distance from origin to the point. Then we are going to see how how to find the distance between 2 points. Okay, I will just giving these names x1 x2 x3 the dimensional space, and let's consider point p a1 comma a2. This is the point a1 comma a2 in the 2D space, and this is the point a1 comma a2 comma a3. Okay, the distance from the initially we are going to find the distance from origin to the point origin. This is the origin 0 comma 0. This is the distance. The distance d equal to the component value of x1, that was a1 square, and the component value of x2, the component value of x2 is a2, a1 square plus a2 square. Similarly, for this one, the component value, this is the distance from the point to the origin. Okay, this is the distance. The component value is a1. For this one is there, this is the a2, and there is something here is there, this one is a3. Now distance equal to a1 x component square y component square and z component square. Okay, by taking root we will get. Similarly, if it is a n dimensional space, okay, then how we can find? This is similarly those things like a1 square plus a2 square, so on, for n square, not taking root to that one. This is the way we will get. Okay, next let's see, if there is a from a point we want to find the distance. Now I want to find the distance between 2 points instead of origin. How we can do that one? Okay, for that, let's consider 2 points. Let's consider this point P The component x1 component is a1, x2 component is a2. Okay, similarly the point q, and here x1 component is b1, x2 component is b2. Okay, similarly here also let's consider in parallel, we can go that way. x1 component is a1, x2 component is a2, x3 component is a3, and another point q, x1 component a1, a2, a3. Okay, now the distance between these 2 points. Okay, here we need to take the distances. We will take the component square and the square root. We just need the x component value. This is the distance. Okay, this is the x1 component value. This value is, okay, a b1 minus a1. Okay, b1 minus a1 square, distance equal to, and then x2 component value, this distance is a2 minus b2 square, a2 minus b2. Okay, now a2 minus b2 square, and we will take whole root, we will get the distance. Similarly for this one also, this is the distance between these 2 points. Okay, it's like we just we can take these two things uh, inverse also, we will get the same thing because square is there. We can consider like that, a1 minus b1 square, a2 minus b2 square, a3 minus b3 square whole root. This is the distance between these 2 points. Okay, similarly if we have n dimensional space, at that time the distance is equal to square root of, we need a square root on top of that one, and we have points from I equal to 1 to n, ai minus bi whole square. This is the distance between 2 points in the n dimensional space. Okay, now we got the how we can represent a vector in vector form, in basically in the matrix representation, how we can find the distance between two vectors and from the origin to the vector. Okay, now let us see how we can do addition and multiplication of the vectors. Okay, for that let's consider a vector a is a1, a matrix representation a2, an. Okay, and b is the another vector b1, b2, bn. By adding these two vectors a plus b, by doing these two things, we will simply get like a1 plus b1, a2 plus b2, a3 plus b3, so on, an plus bn. This is the basic addition. This is the how we can add these two vectors. Now let's see the multiplication. Okay, in the multiplication we have two types of multiplication is there. One is dot product, another is a cross product. What is the difference between the dot product and the cross product? Basically dot product, we are using the finding the similarity between these two vectors, to find the how much is the similarity between two vectors. For that we are using the dot product. Cross product give the dissimilarity, difference It's like for example a matrix representation. If you represent this one like this, the components of A is Ax, Ay, Az, this one, and the components are B's, Bx, By, Bz. Okay, these are the dot products. This dot product is similarity values between Bx, Ax, and By, Ay, and Bz, Az. This is the dot product values. The cross product values, we will get these values. Okay, these are all the cross product values like Bx, X, Bz, Ax, like that we will get. Let's see more intuition to get more understanding on that. Okay, uh, we have A is a vector and B also a vector. When you're doing dot product, mostly we are going to use the dot product. that was that was mostly useful for the machine learning purpose. Okay, A dot B equal to A1 B1 plus A2 B2 AN BN. Okay, how we can represent it is in matrix this thing we already know, the dot product value. We can also represent this one in matrix, represent A1 A2 AN as a row vector and the column vector B1 B2 B3 Bn. If you multiply these two vectors, we will get this only, na? Okay, we'll get this one only. We will get this one only by multiplying these two vectors. Okay, we can tell that the A and B, we can represent A like this and B can represent like this. Okay, this is the thing that we had discussed previously, representation of a vector. The basic formula is the A dot B. A dot B equal to modulus of A modulus of B and cos theta. Okay, dot product of these two points. What is it represent actually? Okay, for that let's going to plot a 2D plot. Okay, that makes our life so easy. Okay, this is the point. Okay, this is the point A. Sorry, this is a point A. This is a point B, and the vector representation is this one. Okay, a point, and this is also a vector representation. Theta is the angle between these two points, and the distance from origin to this point is modulus of A, and the distance from origin to this point B is modulus of B. This is the A dot B we will get by taking the two distances and multiply those things, and the cos angle between these two vectors. How we will get the cos theta value? Okay, if you know the A1 B1 value, it is easy to get. Okay, because we already know A dot B equal to A1 B1 A2 B2, and it is also equal to the modulus of A modulus of B cos theta. Then cos theta equal to A1 B1 A2 B2 by modulus of A1 modulus of B2. By this way we will get the cos theta values. If we just know the point values, everything is easy to find the dot product.